Today, I will show you some machine learning stuff, and it's very specific. It's not only machine learning, but it's neural networks. And I have 0 slides. All I'm showing you in this next 30 minutes is this thing. And unfortunately, even though it's very powerful, it's a great thing, it overwhelms you when you fire that off. And how do you do that? Like this. It's called playground.tensorflow.org. And when you start it, it looks like this. I think they made a mistake in showing too much at first. But first thing we will do is disable all that stuff. So if you try it at home, you scroll down, and then you find a few checkboxes, and then you uncheck all of them. No double clicking. I'm very bad at that. Let me see. It may take 5 minutes. Sorry. Unchecking all of them. We will check some of them again later, but first we uncheck all of them. Then we refresh the page. Oops. And it looks like this. So it's much simpler now because a lot of stuff has disappeared. The main thing, or the thing that you should use to get started is on the right side here. And what you see is a 2-dimensional coordinate system. And on that coordinate system, you have dots, the blue ones and the orange ones. And it works like this. So this is first axis, it's called x1. And this is the second one, it's called x2. And what you have here as an axis, this one, x1, x2, is this thing here. Also called x1 and x2. So this is important to know that there's some sort of connection between those two. And it works like this. So each of those spots, this one, the orange one, the blue one, it is somewhere on that coordinate system. So the input for something has to be x1 and x2. So simple. Now, what the whole system tries to do is you feed in all those blue points, and you feed in all those orange points. And what the system is supposed to do is to learn in which area of that coordinate system will blue points appear, and in which area will orange points appear. And of course, it's silly to do this unless you want to do predictions later. So this is what you see now is the so-called training set, which you feed into the system. So you tell this whole system here, I have a certain point, and it should be blue, and it changes something in that system. I will show that. And later, you feed in something that you haven't seen before, and then you hope that the system will make a good prediction. So, for example, if something appears here, what color will it have? What will you say? What is it? Orange, right. And for us, it's very easy because we're very good at something like pattern recognition. We see the pattern. So it looks like a circle in the middle, and the rest probably is orange. We see that because we have brains. We can do that. But the machine, it has to learn it. And now I will try and make the machine learn that stuff. And by the way, if you have questions, I know it's a big room, but just shout. I don't know. So now I'm trying to train the system, but I can't because I unchecked too many boxes. So there's the play button. And the play button, it actually starts the whole training thing. We can do something else. Number of hidden layers. Reset button is also interesting. So you will see the effect of this in a second. Show test data is also good. Noise level. No, we don't need it. So clicking refresh. So if you want to repeat that, you do the same thing. And now all of a sudden you have this button, which is the play button, and the reset button. And you can do something like this. I'm just making it simpler. So what I did is I configured the neural network, like the architecture of the network. And I told the whole thing just to use a simple and single neuron. So those are the inputs. Remember that. This is x1, this is x2. And this is a so-called simulated neuron. And what it can do, it takes two inputs, this one. It multiplies it with weight, the weight that you see there, and you can change it, like manually. I'm doing it now. And by changing it, you see that something on the right side changes. You see that? This is a very big weight, and you see it expressed in the thickness of this connection here. And I can also change this thing. It's like multiplying this input with a certain number. And what I'm trying to do, like manually right now, is to, maybe you tell me, what is it that I'm trying to do here? I'm trying to adjust those weights that this thing here, whatever this is, I'm trying to separate the blue dots from the orange dots. But what you can see, maybe you see it, is whatever I change here, all I get is a line. You see? How far it is displaced and the slope, the steepness of the line, I can change by changing those weights. You see that? But what I cannot change is that it is a line. And this is because this is how a neuron works, like a simulated neuron. What it does, actually, is to sum up those things, as I said, multiply it with weight, then put it through a so-called activation function, which should not concern you, and then it outputs something, and this makes the prediction. I'm drawing it for a second now. So what it does here is x1 times weight 1 plus x2 times weight 2. And if you do this like in a equation, you may know that this is actually the equation for what? Mathematical people. It's a line, right? So if you do some sort of transformation, at a certain point you get something like, I don't know, steepness times x plus offset, I don't know, b. And this is the equation for a line. So what you see is a single neuron can draw a line. And this is what it does, right? Is it a good line? I mean, is that line good at separating the blue dots from the orange dots? Is it good? It sucks, right? Because you not only see it, but there's also a measure up here. And it tells you how good it is at it. And it's not even 50%. So 53% are wrong. So this is a very bad line. But I suck at like doing this manually, but what I can do is I let this run. It still sucks a lot. I reset it. Sorry, this happens sometimes. Let this run now. And now what it does, it tries very hard to like draw the line properly. And I can, no, I can't. It doesn't matter. It will try for a while, but now you can see the accuracy up here, like how well it is doing, is 40%. No, it's the other way around. So, no, it's right. No worries. So 40% is wrong. So 40% is still wrong. Would you be able to draw the line in a way that it could actually separate the blue from the orange things? With a circle, that's true. But if it is a line, not possible. The circle thing, I think it's even possible here. Let me see. It should be this, right? If it doesn't make any sense, so let's see. Holy goodness. So with a circle, it's possible. And you see the test loss, it's almost zero. So it's almost possible with a circle. But this was something like a trick. This is unusual. So probably most of the time you don't pre-process the inputs, but you use just a line. But I think if you stick to a line, we really see that it's not possible to ever get a good result, right? Because there's just no way. What I can do now, and this is the trick of a neural network, is you add neurons. And I'm doing it. Second one. So the initial weights, which is the thing that is actually variable that you can change. The initial weights, it's just random. It's just something. Now, when I'm starting the training, you see that now we use two lines. And you see how they look by looking at this visualization here. This is the first line, and this is the second line. And now they're combined, in a way that they form this shape. And now the test loss, like how many wrong predictions you have with the testing thing, is 18%, which is much better. Do you think if I keep on training, it would be possible to get close to 0? No. Third line, good, I'll do it. Third line, I'll reset that. And as you may have expected, after a while, you get something that's pretty close to a triangle because you have 3 lines, right? It's not perfect, but it is very close to, well, it still goes down. I think we get very close to at least less than 1%. So this actually fixed the whole thing. So this was good enough. This was a pretty good thing. So we can keep adding things. No, that was wrong, sorry. More neurons, more battery drain, still good. You can't see it, but my fan actually started like working here on my machine. It's quite intense for this small machine to actually calculate that prediction. And you see this thing here is totally useless, doesn't predict anything. This thing here is useless. Probably I already have too many of those, but I could still keep adding things. Doing it again. Okay. Well, it works okay. So it doesn't get any better or much better. So we see probably a good architecture for the neural net, 3 of those. Now, next thing. I said the real purpose of this is not to get a very good prediction for the so-called training set, like the dots that I feed in, but for something else, like for dots that I have not seen before yet. And this thing actually can do it. I think I need to check one more box. Should be called, I don't know. There's something that's called test. You see it anywhere? Where is it? I have. Let's see. Oh, good. Yeah, it's all in place now. Now you see 2 losses here. I don't know why we didn't see it earlier. And this is because there are 2 sets of dots here. I think it's hard to see, but some of those dots, they have a black surrounding, like a black border, and some have a white border. You see that? Is it possible? And the data that I used to train the whole thing, it has, obviously it has white borders. But there's another set of data, and this set of data, it has black borders. And this is like randomly splitting like the amount of information that you have into something that you use for training, the stuff with the white borders, and into something that you use for testing, like how well did I do? And you get 2 losses now. You get one for testing that you use for like, sorry, the other way. You get one for training that you use to train the network and the other for testing. And let's have a look. And you also get like 2 graphs for them. You see that? They're slightly diverging here. They're both going down. Still going down. So training is a little bit better than test, but only with a very small margin. What would you say? If you had the training result like this, is this a good result or is it bad? What do you say? Like intuition. Good? It's a good one. It's pretty good. So this is exactly what we wanted. So some of those spots, we didn't know that they would be there, but we just saved it for later. And we can actually choose how many of them. This is 50%, like splitting 50 for training and 50 for testing. And that's quite unusual to split it like this, but it's a default. You often see 60 for training and 40 for testing, or even 80 for training and 20 for testing. It depends. It depends how many data sets you want to save to make very sure that you have very good results, and it also depends on how many data sets you have at all. You could change it to, I don't know, 80. I think this is pretty common. So that means 80% of those dots used for training and 20 for testing. It's still good. It still works well. But we can do something else, or we can see something else with the whole thing. And this is when I make the neural network ridiculously complex, and I can do it. So this thing allows me to have one so-called hidden layer. This is a hidden layer. It has 3 neurons, but the whole thing allows me to add layers like this, quite a few. And we already know that the complexity is too high now. What it means we will see in a second, because we knew and we saw that just one single layer with 3 neurons, it was enough, right? Like the model was complex enough, the architecture. And it's even mathematically provable that a single layer always is enough to solve any problem. In theory. Practically it's not, but it's provable that any is a continuous function can be approximated using a single hidden layer. But sometimes it's just not practically feasible. And then you can keep on adding layers and maybe give me 1 minute here. I'm showing you something. I said I didn't prepare any slides, and it's true. This is slides for another talk. Oh, there it is. There you go. Now, this is the architecture of the Google network, the inception network for classifying pictures. And each of those things here, of these, is a layer. So there are many layers, and they're even branching. This would be like a complex model for something that's real, not something like separating the orange dots from the blue dots. Because this thing actually can see in a picture what is on the picture, like an example. Maybe you know this funny example. This is a real captcha. It's real. So I didn't get it. Somebody else had to like choose 3 dogs. It's not very easy, especially this thing here. And this, and I don't know, is this puppies or is it muffin? I think we can do it. And this thing that I just showed you, I fed this Chihuahua. It's a Chihuahua. I didn't know before. I fed it into TensorFlow, like the full version of the playground, and this is the result that I got. So it had like 86%. It was very sure, like 86% sure that it's a Chihuahua. I had no idea that it was a Chihuahua. I thought it was a dog, like a random dog. So actually that captcha, this thing here, oops, sorry, this thing here, actually it was meant to like tell the robot from the human, but it's no longer possible, like do it, because the machine can tell me which is a muffin and which is a dog already. But if you want to do it, this is your architecture. And as I said, each of these things is a layer and has many neurons inside. And you may know, or you may like understand and believe that training such a thing is very expensive. And you need a lot of data to train that. And I couldn't do it like with all my money. So that was like an excursion. Hopefully I can go back to the thing now. Yeah. So I'm doing as much as I can now, but more than 16 layers I can't. I can keep on adding neurons here. I'm trying to achieve something, so give me a second. So now I'm beginning the training, and it doesn't look good, right? Goes down. Something good happened. Oh, it's too good, sorry. I have to do it again. Because it's quite good. It should be shitty, I'm sorry. And it's always like, you can never reproduce 2 results. Even if you have the same like architecture and setup of the system, there's a lot of random stuff inside. Maybe I'm changing this for a while. So, regenerate the thing. So, let's see. Oops. As I said, so there's random stuff inside. No training possible in that case. Okay, good. Still not good. You see, I'm getting nervous now. It should be shitty. Give me a second. So if it doesn't work, I will have to like tell you what I was trying to achieve. But it's still so good. I have no idea why. So I will tell you what I'm trying to achieve. Maybe someone can help me to mess it up. It should be really bad. Okay, last try. If it doesn't work, then I will just explain what I was trying to achieve. No. Okay, what I was trying to achieve, and it typically works quite well, I was trying to get those two curves. It's actually two curves, one curve for the training loss and one for the test loss, to get them out of sync. Like to have them one very good and one very bad. More complex data set, not possible. I thought I should try a more complex model, but it just doesn't cut it. No. Ah, good idea. That should be really bad. Right. Maybe, yes. But almost. I will stop it now. Wait. I will at least fake the curve. Now. Oh, shit. Too late. Okay, last try. Increase it. Let's see, or let's say this is the final result. I know I'm just not getting it done. If you saw something like the loss for the training is very low, but the loss for the test is high, what would you say? Is that still a good test result? Or is it still a good training result? What would you say? And what does it mean? You can visualize it here. So I'm having a very hard, oh wait, I don't know. I know how to actually make it done. Think about it while I'm trying to fix it. I'm using a more complex data set. That's what you said, right? It's possible. I thought it was not possible. So what we're doing now, I'm using a more complex data set, like a mean data set. And now I'm trying it again. It's not fair, yes. That was just, oh, perfect. It's exactly like I thought it should be. Like the result is still not good, but it's getting better now. Oh, it's perfect. Thanks a lot. So what it tries is like to do a very good separation between those two things. It doesn't do very well yet. I think we would have it run for a little bit more time. But see, things are actually much more complex now, and it's getting better all the time. You see, the training thing goes down all the time, but the testing, it goes up, right? And this is exactly what I was trying to show, and it obviously was hard to show it with a too simple data set. And you see, this will go on for quite a while. Even with this very simple thing on my machine, it will probably take like 10 minutes until it actually is very good at predicting one thing. But you see, those two things are now diverting. What does it mean? Like, what does it mean? It's called overfitting, right? But what does it mean? I actually did very good at training with my training data, but in real life, which is represented as the test data, I totally suck. I'm not even at, oh, okay, I just crossed 50%. But this is guessing. This is just like, I'm as good as guessing. So what it means is this model here, this thing here, is still too complex so that it's very good at exactly predicting those things if I keep on training, but it's very bad at seeing new things. So it's always like almost an art to make the model and then the training just as complex to still be general enough to make predictions for new things. And this is where I messed up. And this is just like a spiral. It's not very hard. It's a very simple thing. It's just two-dimensional. Now think about training for data. You have 1 million dogs, for example. You don't want to just recognize those dogs, but also the others. And you can also see this here. It's pretty cool. If you know, like I did not, how to probably set it up. Because time is over almost, I will, again, check all of those. So if you try it yourself, that you, again, see how it will look if you start it. And there's much more stuff to see. But all of those stuff, you should probably just ignore for beginning, because it's overwhelming. So this thing here, you just ignore. These things, this is for like how the training works. And this is totally esoteric stuff. So even the most advanced people I talk to, they say, it means something. And there's a paper, read it, but it's almost impossible to explain. Maybe Lian can do it in tweets. I'm trying to make her do it. But you probably won't ever touch this. So this is something you will never touch, so probably you just want to deactivate it. That's it from my side. We still have 3 minutes. Other questions? Anything? Do you like it? Will you try it at home? Who will actually try it at home and do something with it? So many people. This is what I try to achieve. Maybe we have a quick look at the other data sets. This is super simple, like just one line, right? This is harder. This is the hardest. So what I'm doing here, I did this for the circle, remember the circle thing, is that I'm sort of pre-processing the input. I'm not just using the pure input, but this is also common in machine learning, that you do something to the input before you actually feed it into the machine learning. And if you choose the right thing, which I may have chosen now, if Lian isn't fooling me, then it might work well. And we saw it with the circle, that we actually could do it with 1 neuron. That probably takes forever on my machine, right? So I know it's not fair. It's you watching me play. You can do it yourself. I think if you remember like half of what I said, you should be up to my level at least, and then be able to try that out. It's almost art, isn't it cool? Okay. Maybe just, if there's no question, we can finish off with this entertaining part. Saw it in those slides. Puppy or chicken wing. I got all of them right, but there's one thing. This is like bagel or dog, and this is really very hard. And this thing was the hardest. Is it like the bottom of a dog, or is it a loaf of bread? And this thing here, this thing here up there, I got it wrong. But then I thought it was a loaf of bread, but then I saw the feet. You see? It's a dog. So with that, I think we are now good to close it. And thanks a lot. Try it out at home, please.